in light of the ongoing shutdown of the US government. Scientists at NASA are persistently tracking the interstellar comet 3I Atlas, despite the halt in much of the agency's public communication. This week, officials from NASA are prepping to brief Congresswoman Anna Paulina Luna, who has formally asked for the release of new images and data for public examination. Meanwhile, Harvard astrophysicist Avi Loeb has reiterated his demand for transparency, referencing new indications of brightening and non-gravitational motion following the comet's recent passage near the Sun. A collaborative monitoring effort has been initiated among global observatories, set to run through early 2026, to analyze the behavior of the object as it moves further from the Sun. Let's dive into discovery. Since its identification as an interstellar visitor in mid-2025, 3I Atlas has been steadily traversing the inner solar system, and it passed its closest approach to the Sun on October 29th. Around that date, astronomers noted a sudden increase in brightness, hinting at significant outgassing as sunlight interacted with previously shaded ices. Spectral data suggested brief jets of water vapor, carbon compounds, and trace metals being expelled into space. While these occurrences are typical for comets, what intrigued scientists was the acceleration pattern, which did not fully align with uniform outgassing models. The object exhibited minor, irregular movements, prompting researchers to update its orbit and rotation models. Although such deviations are not indicative of anything artificial, they offer valuable insights into the behavior of interstellar material under solar radiation. Despite the federal shutdown, NASA's internal teams at the Goddard Space Flight Center and the Jet Propulsion Laboratory have continued essential tracking. A briefing with Representative Luna has been scheduled to discuss forthcoming data releases and to assure Congress that monitoring activities persist without interruption. Luna's office confirmed that her request was made in conjunction with a Harvard scientist believed to be Avi Loeb, who has been advocating for public access to the latest images. Concurrently, several university-operated observatories and the European Space Agency have joined the observation network. The comet is currently approximately 300 million miles away from Earth and fading, but high-sensitivity telescopes can still gather spectral data to examine how its coma, the gas and dust envelope, evolves as solar heating decreases. This phase is critical. The comet's outward path and changing light curve will assist researchers in modeling its density, spin rate, and internal structure. This data will contribute to the International Asteroid Warning Network's campaign planned from November 2025 to January 2026, which aims to construct the most comprehensive data set yet on an interstellar body prior to its re-entrance into deep space. Scientific importance and theories. The renewed focus on 3I Atlas goes beyond its rarity. It serves as a living laboratory for testing theories on how planetary systems exchange materials. Spectroscopic analyses suggest that its ice and dust show similarities to those found in comets from our own Kuiper belt. Yet distinct ratios, particularly between carbon and oxygen as well as nitrogen-bearing compounds, appear unique. These variations imply that it likely originated in a colder, more distant protoplanetary disk, potentially around a small, dim star. Grasping these details could enhance models of how water and organic material migrate across the galaxy. If 3I Atlas contains isotopic ratios that deviate from those typical in the solar system, it would confirm a broader diversity of chemical compositions among stellar systems than previously understood. An important insight for theories related to panspermia and early planet formation. The comet's irregular acceleration remains a topic of technical discussion. Most researchers attribute it to asymmetric venting from the nucleus, potentially due to uneven layering or rotation, though some anomalies still exist. Loeb and his colleagues argue for an unbiased investigation into the physics behind such movements, not because they suggest artificial design, but because understanding unexpected forces could reveal new natural processes. Both NASA and the European Space Agency have reasserted that available data indicates no signs of anything beyond a natural comet. However, they concur that its unusual behavior does warrant further observation. This measured approach stands in contrast to the divided public responses following the discovery of Oumuamua in 2017, when limited data fueled speculation faster than it could be substantiated. What differentiates this situation is the level of coordination involved. Over a dozen research institutions are sharing real-time observations via the International Asteroid Warning Network. The campaign includes both professional and amateur astronomers, aiming to gather data across various wavelengths, visible, infrared, and radio, to map gas emissions, dust density, and compositional changes as the comet cools. Preliminary data already indicate that the object's composition may change as it distances itself from the Sun, possibly developing a faint ion tail. If verified, this would mark the first documented occurrence of such behavior in an interstellar comet with this degree of precision. Each dataset brings researchers closer to determining whether comets like 3I Atlas are common, messengers from other star systems, or rare fragments expelled under extraordinary circumstances. Implications and what's next, the happenings surrounding 3I Atlas, illustrate the increasingly interconnected nature of space science and public policy. Congressional interest in a single comet might have once seemed improbable. However, the rising dialogue around transparency in space data has made such oversight unavoidable. Representative Luna's engagement emphasizes a new political consciousness that recognizes that discoveries beyond Earth resonate both scientifically and culturally. NASA has announced that all data obtained during the shutdown will be made publicly available once normal operations resume. The forthcoming briefing with lawmakers is expected to detail how these interstellar detections integrate into long-term strategies for planetary defense and scientific collaboration. Meanwhile, the Pentagon's all-domain anomaly resolution office, which handles the analysis of unidentified aerial or space phenomena, issued a brief clarification stating that 3I Atlas is fully identified and poses no security threats. This note was procedural, but highlights the structured communication now employed to clarify the distinction between scientific occurrences and speculative narratives. On the international front, the ongoing observation campaign is being coordinated through the European Space Agency and the Lowell Observatory in Arizona. The aim is to continue tracking 3I Atlas until it becomes too faint for detection, utilizing instruments across both hemispheres to compile a continuous timeline of its development. The data will encompass measurements of its polarization, a characteristic revealing particle size, and structures in the dust cloud, which will aid scientists in estimating the comet's formation. The broader scientific community is already looking ahead to future generations of surveys. Once full operations commence at the Vera Rubin Observatory, it will scan the entire sky every few nights, with sufficient sensitivity to detect many more interstellar visitors. Astronomers anticipate that sightings like 3I Atlas could transform from rare occurrences into annual events. Such a shift would establish these fleeting encounters as a new area of research. Comparative studies of interstellar comets. Each future discovery will enhance the statistical basis for models concerning galactic dynamics, illustrating how fragments are ejected from planetary systems and how frequently they pass near stars similar to ours. For now, 3I Atlas continues its outbound journey, fading but not beyond measurement. In a matter of months, it will slip beyond the capability of most telescopes, leaving behind vast amounts of data and providing a clearer understanding of how the Milky Way's systems share matter across immense cosmic distances. Outro, although 3I Atlas is fading from our view, the data it leaves will significantly influence how we approach the study of interstellar visitors for years ahead. It has united scientists, lawmakers, and observatories in a unique global collaborative effort for discovery. A reminder that even across light years, our solar system is never entirely isolated. Enjoy.